The title of our term final project is Explore malicious IP core attack the baseband signal of users based on game theory models. This may not be a side channel attack. It is more like an attack from malicious hardware at the physical level. First, I need to introduce some background information on this hardware attack. Field programmable gate arrays are integrated circuits that implement reconfigurable hardware. They are used in modern systems, creating specialized, highly optimized integrated circuits without the need to design and manufacture dedicated chips. At the same time, because of the flexible programming properties of FPGA, it is often used to implement various communication protocols or be used as network nodes. As the capacity of FPGAs grows, it is increasingly common for designers to incorporate implementations of algorithms and protocols from a range of third-party sources. And the most important tool is IP core, which is called intellectual property core. As essentially element of design reuse, IP cores are part of the growing electronic design automation industry trend towards repeated use of previously designed components. The monolithic nature of FPGAs means that all on-chip circuits, including third-party black box designs, must share common on-chip infrastructure, such as routing resources. The IP core is a black box design. At the same time, due to property rights issues, many IP cores have been designed by third parties. In this experiment, we intended to investigate the impact of malicious hardware IP cores on baseband communication signals. The following is our conception of the security application scenarios. For the scenario 1, the manufacturer does not know which IP core is malicious, and the malicious IP core interferes with the baseband signal transmitted by the user indiscriminately. For the scenario 2, the manufacturer implants a malicious IP core to directly detect the user's baseband signal. The user uses noise to cover his signal and pays price for the noise. Here I mainly introduce the application scenario 1. The manufacturer does not know which IP core is malicious, and the malicious IP core interferes with the baseband signal transmitted by the user indiscriminately. Our goal of this project is to reduce the impact of the sense on the interference of baseband signals. The specific implementation method is to find the Nash equilibrium through the game theory to avoid greater losses. Here we introduce the construction of the model. In the absence of malicious IP cores, the baseband signal is simply the superposition of binary signal and white Gaussian noise in the system. The receiver makes an optimal decision by evaluating vision risk. Mu is the baseband signal level. This is designed by the manufacturer. The manufacturer can expand the absolute value of the level difference of the baseband signal to make the binary signal easier to be distinguished by the receiver. But at the same time, the manufacturer also needs to pay a certain price for the optimization of the signal. Sigma is the effort made by the attacker to interfere with baseband signal. Sigma is also the variance of the Gaussian distribution. The attacker makes the baseband signal more indistinguishable by increasing the variance in the baseband signal. Here we assume that the malicious IP core uses Gaussian distributed interference to interfere with the baseband signal. The advantage of this assumption is that the system noise is also Gaussian white noise, which is convenient for the malicious IP core to hide itself. Permanently zeroing or permanently setting the band signal to 1 or directly flipping the baseband signal will greatly increase the probability of being discovered directly. In order to make the game more realistic, both sides of the game need to pay the corresponding price for their actions. For example, the manufacturer cannot increase the level of value of the baseband signal infinitely to make the value of the baseband signal infinitely easy to distinguish. When the level discrimination is larger, the manufacturer needs to pay a corresponding price for it. In this experiment, we assume that the value of the cost is proportional to the absolute value of the level. Here, the game model has been initially constructed. This is continuous game. We will use Nash equilibrium existence theorem in subsequent experiments to determine the existence of Nash equilibrium in the game, and use the dynamic best response algorithm to find the Nash equilibrium. Below are our references so far. We mainly refer to the literature on the left for the background investigation of FPGA and actual security issues, and mainly refer to the literature on the right for the construction of the game model.